So here's another thing that we're going to need in order to do our integral that we're trying to set up. We're going to need to know what the integral of secant cubed is. You'll see how this comes out. It actually does. And doing integral of secant cubed is tricky, and it's a really clever technique to do it. So here's what you do. So it's an integration by parts, basically, but it's an integration by parts that sort of chases its own tail a little bit. I'll show you what I mean. So first of all, parts involves having a product, so we need to split this up into some kind of product. So we're going to say that the integral of secant cubed x dx is equal to the integral of secant x times the integral of secant squared x dx. So what this does is basically, like, we know that the antiderivative of secant squared is tangent. We know that the derivative of secant is secant tangent. So like maybe we can get those to work together somehow. So that's in fact what we do. We call this one u and we call this one dv. I know some of you guys set up your chart a little differently than I do. I like to put u equals secant x up here, and then I put my dv down here. That way, like, it's always integrating going down. Yeah, whatever. I've left my equal sign off. You can arrange that however you want. So then the du is going to be secant tangent, right? Because derivative of secant is secant tangent. And the v, I'm going to integrate this antiderivative of secant squared, is tangent. All right. So then I can use that the integral of u dv is equal to uv minus the integral of v du. So that's parts. It's good. Like, it's all good to come back to these things and keep remembering them too, because you'll use all of this stuff in your Calc 2 and Calc 3 and higher classes. All right. So when I put down uv, so my integral secant cubed is the u dv. So my uv is going to be secant tangent. So equals secant x tangent x. Minus my integral of v du. So I'm going to have tangent integral of tangent times secant tangent. All right, so clearly I can combine that a little bit. And let's not forget what I have over here as integral of secant cubed x dx. That's what I'm trying to do. Equals secant x tangent x minus, and we can call this the integral of tangent squared x secant x dx. All right. Now, what this allows us to do is use another trig identity. See how, like, all the math is in this stuff, and that's what I like about it. So you know that secant squared x is equal to tangent squared plus 1. If you didn't know that, oh, that's a plus sign. If you didn't know that, take the equation sine squared plus cosine squared equals 1 and divide both sides by cosine squared, and you'll get this. All right. So this, but what I have here is tangent squared. So I can rewrite that as tangent squared equals secant squared minus 1. So I did all this work to get this tangent squared in here, and I'm going to throw that tangent squared back into secant squared form. That's why it seems like I'm going in circles. But you're going to see how going in a circle actually benefits us and brings us back to something. So if I replace this tangent squared with secant squared minus 1, then I have integral of secant squared x minus 1 times secant x dx. I'm going to distribute the secant x back. And so now I've got secant x tan x minus integral of, I guess I split these out of my notes, but I'm going to do it in 2 steps. Secant cubed x minus secant x dx. So now I'm going to split this integral up a little bit. So I have equals secant x tan x minus integral of secant cubed x. And then since I have minus minus, it's going to be plus integral of secant x dx. Now, here's where it looks like I'm going in circle and chasing my own tail. I started with secant cubed x. I did some simplifications. I still have secant cubed x in my answer. However, this one's a positive secant cubed x, this one's a negative secant cubed x. That means I could take this secant cubed x and add it over to the other side and just pick up a factor of 2 over here and then divide it out. And that's a good standard mathematical trick. Like, I start with a certain thing that I don't know, I manipulate around, I get something that has my unknowns still in it, and I throw those unknowns together and then solve from there. So another thing that's going to happen is I'm going to profit from the fact that the last thing that I just did was the integral of secant x. So this is why we needed to know what the integral of secant x was. The integral of secant x is ln of absolute value of secant x plus tangent x, right? That's the last thing that we did, was figure that out. All right. Over here, and then we'll just copy everything else down. So I have equals secant x tan x minus integral secant cubed x plus that. Let's put the plus c on here. All right, because I did that integral. Even though I still have an integral hanging out here, I'm about to take it out. So now that's the trick that we do. We say, all right, I know that the integral of secant cubed x dx is equal to all this stuff. And so what I do is just add the integral of secant cubed x dx, dx, add that back in onto both sides. Then what I'm going to end up on the left is 2 integral secant cubed x dx, and it equals this thing, secant x tangent x, plus this thing, ln absolute value secant x plus tan x plus c. So now, see, I never managed to solve, really, for what integral secant cubed, except for something that was still in terms of what I didn't know. But by putting both my unknowns together, then I can just divide both sides by 2. And then I have integral secant cubed x dx equals, so I could put the whole thing over 2, but I find it a little easier to write if I do 1/2 secant x tan x plus 1/2 ln absolute value secant x plus tan x plus c, and that is what the integral of secant cubed is. So again, in your homework, you can take this as a given result. So in your homework, whenever you hit an integral of secant cubed, you can just use this antiderivative. All right, but you see what a great technique it is to review all these different things. There's so much that goes into doing these integrals, and a lot of what mathematics is about is not so much always about learning new things, sometimes about taking many things that you learn in many different ways and drawing them all together to solve a problem.